Hello everyone. Today we're going to start doing another day of Advent of Code. I'm going to start with day 7. I did day 6 off stream and off video. It was a really quick one because the parsing was basically the same as what I did in Advent of Code Puzzle 4 because I had to group these together, basically combine them all and do some operations on them. It took me about 10 minutes. So we're going to drop into day 7, Handy Haversacks. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. Issues in luggage processing. Okay, so that's what we're dealing with. Your rules are being enforced about bags and their contents, and the rules are going to be the input. Interesting. Bags have to be color-coded and must contain specific quantities of other color-coded bags. Apparently, no one responsible for these regulations considered how long the task would take to enforce. Example, consider the following rules. Light red bags contain 1 bright bag, 2 muted yellow bags. So like something about a particular color. I lost my spot. Hold on. 1 second. Back there. Okay. So something about like different colored bags contain different other colored bags. Specify the contents for 9 bag types. In this example, every faded blue bag is empty. Every violet plum bag contains 11 bags. 5 faded blue and 6 dotted black, and so on. Sure. You have a shiny gold bag. If you want to carry it in at least one other bag, how many bag colors would be valid for the outermost bag? How many colors can eventually contain at least one shiny gold bag? So a bright white bag can hold your shiny gold bag directly. Sure. A muted yellow can hold your shiny gold bag directly plus some other bags, which is here. Okay. Dark orange bag can contain bright white or muted yellow, and muted yellow can contain shiny gold. So we're going to be doing a graph problem basically. Because it's a graph problem because we have nodes which are different colors of bags. And at the end of our tree is going to be something like, all right, let's start taking notes. So that's going to be the inputs, and then we're going to do aoc7.c, or .rb. We're doing Ruby still. So this is going to be something like shiny gold bag is mine, and then that can be contained in muted yellow, and muted yellow can be contained in dark orange. So that's like how we're going to have to start working on these chains, right? And a light red bag which contains bright white and muted yellow, either of which can hold your shiny gold bag. How many bag colors contain at least one shiny gold bag? The list of rules is quite long, make sure you get all of it. Okay, and our inputs look something like this. So what is this? To think about this problem, I'm thinking about what's the data structure I want to build. And the data structure I want to build is something like a relationship between a bag color and a number and color of bags. So I want to express that colored relationship. So let's start out with, I think I'm going to build a class for this. A struct is a little bit not descriptive enough. So class like bag relationship, right? And it contains so we're just going to initialize it from an input string, and then so we're just going to .new every single line of the input, and that should help us get what we want. It's going to contain a containing color. It's going to contain I guess an array of contained bags. And each contained bag is going to be a number and a color. So that could be a struct. So that could be like a struct container containment struct. I don't know. How did I initialize struct again? Yeah, struct.new. Stop. Why did my headsets keep on wanting to auto shut down? struct.new, and that's number of bags, and the color of the color. And then contain bags is going to be an array. And I think those are all the things that you really need to care about. So the contain bags is going to be an array of these containment structs. Okay, so what does the parsing look like? Given a single string, it's going to look something like this. So normally I would want to do Okay, we're going to start by breaking this down into the color bags contain rest of string. Right, so we can do you can do a parsing step that's just like colors rule match equals input string dot match, and we'll do so this is a capture group. It's going to be named color, and it's just going to be letters A to Z repeated some number of times. Letters A to Z or spaces repeated some number of times. And then the word contains, and then, or I suppose I could put the space contains here. Space, and we're going to also make this beginning of string, this end of string, and then a second capture group that is going to be a containment spec. And this is going to be basically anything. It's going to be the rest of the string, effectively. Okay. If this doesn't match the color rule match for some reason, we've definitely errored. So we're going to do binding.pry here. And otherwise, right, that's how I grab, where's my must match? Was it AOC4? Yeah, so we did stuff like this, and then we got the quotes out from here. Oh, it's a colon. It's a symbol. So Ruby symbols are with the colons, and which is sometimes the keys for some things. Other keys are given via quotes because, reasons. Okay, where are we going? We're going back in AOC7. So if there is a color, then that's great. We get that. I know I'm going to run I know you probably don't need the strip, but I'm just going to do it anyway. So strip just gets rid of the white space. And then the containment spec is the next step of things. Actually, this should just be at containing color. I don't even need to do anything else to process that. Okay, and then we grab the spec out of everything else. Now this is going to be a comma-separated list of specs. So we're going to do, maybe I might combine these steps later, but this is how I'm thinking. Dot split on comma. And now we split on comma, so we should have an array. It might contain 4 orange bags, comma, 3 bright white bags. Then the parse is going to be something like specs.map do. So for each spec string, we will first do a match. So spec string.match. It's a number 0 to 9. Now I'm getting the number now because I assume that we'll just need it at some point in the future. It's not technically required as part of the problem, but it doesn't hurt. And then it should be a space. I don't like dealing with white space, so I'm just going to do a strip across all after splitting anyway, because I assume that at some point I'll need to do something like that. So I should only have the like 3 bright white back. So the spec string should be just this part right here. It might also have the period at the end, which will be annoying. I can figure out how to strip that later if I need to. All right. That match 0 to 9. Space, a color, which should be A to Z and spaces, space bags, and then we want to return a containment specification.new with the number of bags, which should be spec matched number, and then the spec match color. There we go. And that should be equal to contain bags. There we go. And that should get us a bag relationship with the 2 different colors. And that, I think, just start out with printing out what the end result of this is. So do our usual, split on lines. Declare the class, and then for each line we just do a bag relationship.new and see what the end result is. All right, this should be straightforward. What do we get? Okay, we didn't get a match. Why didn't we get a match? Input string, what do we have? There's a new line at the end. Oh, I didn't account for the new line. That's probably why. So we're going to inputs. We're just going to map a strip as well here, because I just solve many white space problems with that. I think I might need the dot at the end as well here. Okay, did I phrase my things correctly? It's question mark, that plus, yeah. Okay, that looks mostly correct. Then let's do the usual and throw this into regex 101. Okay, regex 101. The color, oops, contains that. Okay, this asserts position end of line. Good. Name capture group color matches single present character in that. A to Z and space matches space, literally case sensitive. So this should be lowercase letters A to Z space, and then plus matches it between 1 and unlimited times, giving back as many as needed. Yes, that seems correct. Then a name capture group matches any character except for line terminators. matches between 0 and unlimited times. I think I want actually this to be a literal period. So, because that's the end of the sentence. Oh, contain. Muted white bags contain. Is it contain or contains for all these rules? I think it's contain for everything. So I just put the literal wrong thing here. That's fine. Uninitialized method, that for nil class. Oh, that's fun. Oh, did I actually run it? Yeah, I did. That's in line 23. No, it's line 16 in map. Containment specs. Sure. Let's do a binding.pry here. Okay, containment spec.split on comma. Sure. Dot map and colon strip. Okay, so we don't know what failed. That's bad. I guess it's if containment specs is nil, then binding.pry. And then figure out what happened. Wait, it's not in, oh, it's in line 17? Line 24 or 17? Why are you failing? Oh, it might not be a spec match. So I think this was the third input. Bags, bags, bags. Contain no other bags. Oh, that's fun. Maybe that's what's happening. It's getting to this one. If not spec match, then let's try that. Okay, and how do I do a custom toString in Ruby? Because now my printout is happening, but it's not really helping. Okay, so maybe I need to also define 2s for this. And what we're doing is just saying we're just going to get some diagnostic information, nothing too crazy. Oh, come on. There we go. So let's look at like dark line bags, right? I also don't want the word bags to actually be in the colors here. So I think I need to add that word there to... Okay, color equals posh orange, spec equals blank. So what happens with posh orange bags here? So I should look at the ones that fail to spec and see why. This is where I would love to have a pipe less. I wonder if that actually exists. Nope, it's not. Darn. Okay, we're going to just do like the first 10 inputs and try and find something that fails quickly. Dot slice, or I guess it's dot take, I think. Okay, dark browns has no, drab brown has no spec, the third one. Why does drab brown have no spec? It's because bag and bags could both be there in the pattern. Now I get a drab brown spec that is useful. Okay. So now we need to do the graph portion of this. So the next step is how many colors can eventually contain at least one shiny gold bag. This is effectively a reachability problem done in reverse. Did I solve the big problem? I feel like solving the big problem here is not a good idea. All right, now we need to start a map, right? Because we have this bag relationship, we want to look at the number of bags that contain a color here. So this is going to be a map from color to bags that contain that color. Now, we probably could have done that without doing the rest of this parsing, but this is more fun. So for each of these maps, as a side effect, we're going to, this should actually be hash.new, that. So it's going to be a map from color to array of strings that contain that color. Which is not, we don't actually want an array, we actually want a set, but for the sake of argument, we can make it an array and then set them later. I suppose Ruby sets, how do those work? And this, I guess, should be set.new technically. Color to bags that can't contain that color and we're going to actually add transitively as well. It's transitively because what we want is a bag that can contain that color directly, or it can contain a color that can contain that color. Then we're going to have to do basically a number of passes on this hash to eventually make that stable. But for the first step here, what we have is contains relation for the containing color dot add want to add the string that is the spec match color. And then shiny gold was our bag, right? Shiny gold, yes. So let's see what we get with the first pass. How do I define, I guess I don't need to. Oh, it's like an accessor or something, right? For class variable Ruby. It's like :adder or something. attr accessor. Yep, you can do all that things. Okay. So now that works. Oh, and then this needs to be that. These are instance variables, but can I do a class variable with attr accessor? Maybe not. Oh, it's like it's something something self, right? Self dot. Yeah, so this isn't gonna work here. We're in a completely different realm. So self dot contains relation, and this making this return the class variable makes sense. So the class variable here is bound in scope to the entirety of this class. There's only ever one of it for all of these objects, but whereas containing color and contained bags, I want those for each object. That's the double at versus single at. That's self dot versus not self dot. Okay, all of these contain it directly. That's fun. Now we need to do the transitive step. So anything that can contain one of these classes also can contain it. Okay. Okay, given a color, the original containing set equals this contains relation for that color. And we're just going to use length comparisons because this should be totally increasing all the time. Then what we want to do is make a new set whose contents are the merge of all of those. So we want that reduce so starting with the original containing set, then for each color we want to merge that color with the set of colors that the contains relation has that can contain that color. So basically, for each color in the set, in the original containing set, we will start with the original containing set and we will merge in all of the things that can contain that color. And we're going to do this while what I actually want is a do while loop, but basically while this set keeps on changing. If I knew the maximum transitive length, this would be easier, but I don't off the top of my head. I could do it one time per color in the entirety of. Well, that might take forever, but I suppose that we can try it. This is weird. All right. Start with the result, merge in all the contained relations in every color that's in the result already. There's a much more efficient way of doing this, but nonetheless. Let's see how long this takes. This is coded so inefficiently. Where is this? 19? $431. If this is at all right, I will be very shocked. Your answer is too high. Okay. Well, let's start with not bothering with any of these and make sure that my answer is too low. That's 431. So the merge is not doing anything useful anyway, which may mean that the color relation here is wrong. Is it making the same set each time somehow? That would be annoying. Oh, right. I need to do something like comma v goes to that. Something like this. If you don't wrap it in a lambda function, then you end up getting like starting with the same set each time, which is annoying. 0. But if I then do this code again, what do I get? Still 0. Well, it was nice knowing you. Maybe I want the set containing V1. And I assume that this is not actually doing anything. Yes, okay. That I can work with. Shiny gold can contain shiny gold. Is that what it's saying here? Oh god. My hash.new is off. That's sad. Hash of grades and options. Hash.new. Hash key block. Returns a new empty hash. That's what it is. It's given a hash and a key. It returns h of key That's what I want. Right? Because I want a new set each time. There we go. This, and so I got 4 there. But if I comment all these in, I get no such method error. Well, at least I'm trying. Okay. So now I want to look up iterable Ruby reduce. Make sure I've got the ordering of this correctly. Oh, is it memo and then set? Sure. So set then color. They call it memo. It's just like the thing that you carry in every time between different reduce operations. Can't add a new key into hash during iteration. Oh, that's sad. So the result equals this. And I want to reduce across. Starting with results. Think I could do something like that. And then dot length. 25. Let's see if that's right. That's not the right answer. Oh, it's not even going to tell me it's too high or low? That's sad. Am I going to make it print out the chains for me? That's going to be sad, but I think I have to. Okay, let's start with not doing any of this. So we have 4 colors, and we don't need to print out this anymore. And those, do I not have anything anymore? What? How did that happen? Oh, because I actually have to do this operation. Oops. Okay. Yay for side effects. A set of 4 things. Plate orange, stripe lavender, pale brown, wavy blue. Shiny silver. Striped lavender. Hmm. Oh, I got the things that shiny gold contains, not the other way around. That's weird. Plate orange, striped lavender, pale brown, wavy blue. That's not what I want. But that makes sense, I suppose. So what I actually contain... I want... Oh, I want to say that this color is contained in that color. Right? I want the other relationship. So it's not contains, it is contained in relationship. How do I do that? So is contained in relation. I suppose I don't really need to call it relation. I can just call it is contained in. And then what I really want is for each spec, I want to reverse this order. Okay, so what do I have now? Oh, all my stuff is done. No. Okay, is contained in, gets here, 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 here. And I'll deal with the transitive in a second. Alright. Light chartreuse, striped beige, vibrant chartreuse, dotted lavender. Vibrant chartreuse, dotted lavender, bright chartreuse, or light chartreuse, and striped beige. Okay, this looks more like it. Up here. Now we need to do this thing. Now what does it give us? Can't add a new key to hash during iteration. Well, duh. And that's at line 18, right? Can't add a new key to hash. There's not a hash, it's a set. I suppose it's a set with a hash in it, because that's probably how they implement it. How do I do a repeat loop Ruby? Because what I actually want to do is just do this a number of times equals the number of keys in here. Okay, I think I can do this. There we go. $242. Is that it all close? All right. That's the right answer. Okay, part 2. It's getting expensive to fly these days, not because of ticket prices, because of the ridiculous number of bags you need to fly. Consider again your shiny gold bag and the rules from the above example. Yep, so shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plum bags for 32 bags. Of course, the actual rules have a small chance of going several levels deeper. Even if the nest, be sure to count all the bags, even if the nesting becomes topologically impractical. How many individual bags are required inside your shiny gold bag? That's the thing that all of the other stuff that I built is basically meant to count. Okay, let's use the simpler example to start with. Okay, so the way to do this is probably recursive. So it's oh really, I need a bag map. So I got all the relationships, right? And this is just this. What I actually want is a way to look up the relationship by name. So I want to map from this to so given a line, we want we have the relationship. We do rel dot that. So we're going to have a map from the containing color to the whole relationship. And then turn this all into a hash. And then develop a function like count of bags per color. Given a color, it returns 0 if relationships for that color dot contained bags equals so given just for the contained bags, we want to go through sum and spec, and then for for the spec, we want to do sum plus spec dot number of bags. Okay, first we return 0 in the base case. In the recursive case, we return color dot num contained bags plus contained colors. Equals so get the number of contained bags plus I want to get for the relationships for that color dot contain colors, and then reduce across those starting from 0 a sum for each color, the count of bags for that color. And hopefully the tail recursion here helps a little bit with the size of the stack, maybe. We'll see how badly this goes. How bad is this going to be? Undefined local variable or method relationships, sure. Reduce for no class. Oh, that's bad. So this is at line 61. How does relationships for color not have a color? This is saying at line 62, which is here. Oh, no, this is at line 24, which is in number of contained bags. Equals containment specs dot map that. If there's not a spec match, return that. Otherwise, how does it get nil? dark violet. What does dark violet have? Contain no other bags. So since it contains no other bags, in this containment spec, you try and split it like this. And then contained bags equals containment specs dot map. So I want to know what happens here. Right, so it's the array containing no other bags. So when I do this, there's no spec match, so it should return empty array. No, I don't want an empty array here, do I? If it doesn't match, what I want is this to be skipped. So this has to be flat map. And otherwise this has to be that. Because I'm annoying. Because we're doing options. Okay. So that happened. That happened. Wait, how did it skip all the way over here? I don't know how to... Still not the best at all this debugger stuff. Need to get better at that. So it never gets down to that point. What the hell? Is this return bad? Maybe this return is doing something super weird. That's possible. Okay, so what do we have now? At contained bags. This should be an empty array. That makes sense. That's what I want. $12. So at this point, I'm just trying to walk through things and figure out what happened. 2. Oh, I need to multiply the count of bags per color times the number of bags of that color. Right. So really the is contained in relationship, or the contained bags relationship also needs to be a map. Right. Oh, this is actually just that. That's funny. So there. I've got the attribute here. Got this here. What I'm learning here is just like make everything a hash. Why bother with arrays unless you truly don't care about accessing by any index? Okay. So now I've got count of bags for the color times the number of times that bag color appears in the root level color, which is wrong element type at string 0, expected array. Type error. Oh, that's fun. Oh, because this flat map still. God damn it. And let's get rid of this binding.pry, just because I wanted to see what the code does without it. Undefined method number of bags for no class. Where is that? That's this, right? Okay, dark violet, which is the dark violet bag contain no other bags. Why is it trying to search through for that? What's the stack? Show stack. We're recurring through num bags for color of color. Can I go up? So I'm looking for dark violet. I'm on line 68. Shifts color dot contained colors is nothing. So that dot reduce 0 should still do nothing, right? Right, this makes sense. Why is this executing anything? That also makes sense. Why is it trying to do anything with this? I mean, I can rule it out, but it just seems so useless. I don't know. I suppose I can just solve it, but this feels weird. 2 still. Well, I suppose I should memorize all this stuff, right? So if there's a memo for that color, return that memo. Otherwise, do this. Hopefully there's no circular dependencies. And then I also want to put the memo at the end, which is part of my benefits, a debugging memo and a useful memo. I don't think this recursion's working correctly. Oh, I probably need to do sum plus, right? Something isn't right here. Dark violet bags contain no other colors. Sure. So the number of bags contained is 0. Set the member for that color equals 0. Otherwise, is the number of contained bags that you have plus the number of bags that they contain times the number of them that you have in you. I suppose I could say one. I suppose what you actually want is to count the tree size, right? This might be easier to define in terms of tree size. Otherwise, it's 1 plus, and then map this function across all the other ones. But it's a multi-tree sort of, so you have to multiply it. Is this just being obtuse because it doesn't like the extra line? Is that what this is? Okay, hold on. Relationships for color that contain colors. Reduce, starting at 0, across each of those colors, the count of bags for that color. Given these memos in relationship in colors, times the relationships for that color, times the number of bags for this color. I'm using the same color twice. That's why I'm shadowing. God damn it. Count of bags for that color of the inner color times the relationship for the outer color times the inner color. That's why. 127. Zero. $126. Okay. Going back to the old definition, after I fix the shadowing thing, fixes that problem. So let's go back to the old rules. See how long this takes to calculate. 1,700, whatever that is. Let's hope that looks very large. I would be surprised if this is the correct answer. That's the correct answer. Okay. Well, that was amusing. Thank you everyone for joining me for a quick experiment in learning how to do all of this, and hope you find it relaxing and enjoyable and maybe learn something. Have a good one.